this is another example of the diffraction grating. So suppose there's 500 ruling per millimeter, means 500 lines per mm. Okay, and the angle between the first two maxima is 26. Okay, so we can mark it down here in the figure. So that means the theta 1 is 13 here. So if we want to find the grating spacing, we can just use the concept to solve it. Okay, 500 ruling per 1 millimeter. So in 1 millimeter divided by 500, it is the grating spacing. Okay, so this is the very first part. Every time we have to calculate it, so make sure you make the unit correct. And find the wavelength, so we can just use the d sine theta equal to n lambda. Okay, so we have substituted already. I think this part is quite straightforward. We just recall the equation here. And then part C is found the angle between the central line to the second order. Okay, so that means we want to get the theta 2. Okay, so once again, because it's grating, we just have the d sine theta equal to n lambda. And because we want to find the theta 2, so the n is 2. Okay, then we can get the theta quite straightforward. Okay, and then part D, we determine the greatest order of diffracted beam. Do you aware there is a greatest order? Because the light pass through the grating when the angle increase, but it can't increase too much. There is a maximum. Okay, so you can imagine the light will not bounce back by the grating, right? So the light must pass through the grating. Okay, so the maximum value, theoretically, the maximum value is 90. Straightly forward, it won't become 90, right? But it set the margin for us. So we substitute the theta as 90 degree. This is the margin for us. Okay, so we can find the n here is 4 point something. But if we talk about the order number must be an integer, so it is 4 instead of 4 point something. Okay, so this is the greatest order. But the question asking us not just the greatest order, but how many bright lines in total we can observe. Can you imagine? There is a central bright fringe, okay? And then we have fourth order. So there is 1, 2, 3, 4 on one side, and then 1, 2, 3, 4 on the other side. So in total, how many bright lines we can observe is 3 plus 1, 4 plus 1 plus 4. So it is 9 bright lines in total can be observed. Okay. So this is the very important idea about the grating. And then to find the third order, if we found that the third order line is coincident with the second order line of another light source. Okay, then find the wavelength of that light source. Once again, the same equation. Okay, this time we consider the theta 3. Okay, so the theta 3, so the order number is 3. And for the new light source, so the theta, you say the second order, so we do theta 2, so the n is 2, and the number is unknown because it's another light source. And what we know is this theta 2 is equal to our original theta 3. Okay, so by solving this two equations, okay, we can get the new lambda. Okay, so the new lambda is this value, then it is what kind of colors? Now let's record it. The color range for visible light is from 400 nanometer to 700 nanometer. Okay, the longer one is red, the shorter one is violet. So this 6 point something times 10 to the power -7 is closer to the red side. So we will regard it as the red color here.